Chapter 2: Linear Functions. Imagine placing a plant in the ground one day and finding that it has doubled its height just a few days later. Although it may seem incredible, this can happen with certain types of bamboo species. These members of the grass family are the fastest growing plants in the world. One species of bamboo has been observed to grow nearly 1.5 inches every hour. In a 24-hour period, this bamboo plant grows about 36 inches, or an incredible 3 feet. A constant rate of change, such as the growth cycle of this bamboo plant, is a linear function. In this chapter, we will explore linear functions, their graphs, and how to relate them to data. The first section is learning linear functions, and in this section you will represent a linear function, determine a linear function in increasing, decreasing, or constant, calculate and interpret the slope, write the point-slope form of an equation, and write and interpret a linear function. Representing a linear function in function notation. In equation form, you can write y equals mx plus b. And in equation notation, that is f of x equals mx plus b. In the example of the train, the previous page about the train, we might use the notation d of t, in which the total distance is a function of the time t, and the rate m, that is in meters per second. And we can write the equation of that as d of t is equal to a3t plus b. Let's take a look at representing a linear function in a tabular form. Look at this table. You can see the relationship here between the distance from the station and the time is represented. We can see that the distance changes by 83 meters. Look at this, from 252 to 333, from 333 to 416, from 416 to 499. The difference is 83 meters. And that is for every 1 second increase in time, from 0 to 1, from 1 to 2, and from 2 to 3. And this is the equation of that table. Now the question is, can the input in the previous example be any real number? About this, d of t is equal to 83t plus b, whereas t is time. And our answer is no, yes. The input represents time. So while non-negative rational and irrational numbers are possible, negative real numbers are not possible for this example. Do you agree? The input consists of non-negative real numbers. Next one, we can represent a linear function in graphical form. Let's use the same example, whereas we have d of t is equal to 83t plus 250. This is the graph of the linear function, and it is a line because the rate of change is constant. What is a linear function? It is a function whose graph is a line and can be written in the slope-intercept form. F of x is equal to mx plus b, where b is the initial or the starting value of the function, where input x is equal to 0, and the constant rate of change, or what we call the slope, is the m. So the y-intercept is the coordinates 0, b. Look at the first example. The pressure P in pounds per square inch, or PSI, on the diver in the given figure depends upon her depth below the water surface, d, in feet. This relationship may be modeled by the equation P of d equals 0.434d plus 14.696. Let's reinstate this function in words. So we need to describe each part of the equation. For this, the pressure as a function of depth equals 444 thousandths times depth plus 14 and 696 thousandths. As you can see here, the initial value at the beginning is 14.696. So meaning here, six. That is the pressure in PSI on the diver at a depth of 0 feet. That's 0 and 14.696, which is the surface of the water. Then the rate of change, which is our slope, is 0.0434 PSI per foot. This tells us that the pressure on the diver increases 0.434 psi for each foot her depth increases. Next, determining whether a linear function is increasing, decreasing, or constant. So we know a function f of x equal to mx plus b. It is increasing when m, your slope, is greater than 0. It is decreasing when it is less than 0, like this. This is increasing, this is decreasing, and when m is 0, it is a horizontal line, it is a constant. Next is calculating and interpreting slope. Do you remember the slope? Rise over run. So the slope m is the delta y over the delta x, that is the change in y over the change in x. This change in y, that is a change in output, or we call it the rise, and this the change in x, that is the change in input, or that is the run. So remember, rise over run. So change in y, you go up, so rise and run, x2 minus x1. So take note of this. Slope is y2 minus y1 over x2 minus x1. Let's try an example. If f of x is a linear function and 3, -2, and 8, 1 are points on the line, find the slope, and then answer the question, is this function increasing or decreasing? So remember, our slope is change in y over the change in x, change in the input. So let's say we have here x1, y1, x2, y2. So the formula is y2 minus y1 over x2 minus x1. So our y2 is 1 minus y1, -2 over x2 minus x1. 1 minus -2 is +3. 8 minus 3 is 5. So this is our slope. Or we could write it if you want in decimal, 0.6. And since the function is m is greater than 0, so it is increasing. Okay. Example number 4. The population of a city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year if we assume the change was constant from 2008 to 2012. So as you can see, that population increased from 23,400 to 27,800. So it increased by, when we subtract this, let's see, the 27,800 minus 23,400, it increased by 4,400. And then at that time, 2012 and 2008, that is in 4 years. So that is like 4,400 over 4. 4,400 people over 4 years. When we divide that, is equal to 1,100 people per year. So the population increased by 1,100 people per year. So that's how you analyze your slope. Next one, point slope form. The point slope form of a linear equation takes the form y minus y1 equals m times x minus x1, where m is the slope and x1, y1, and x and y coordinates are a specific point through which the line passes. So let's have this example here. What is our slope here? Rise over run. So let's say from this point to this point, rise. So from this point to this point, we can go up. That's negative 7, 1, up to here. That is negative 7. Wait, sorry, I can't see. What is this? Okay, so let's say this is from negative 7. If you go up here, that's like negative, that is 7. Sorry. And then from rise over run from here to here, that looks like very close to 4. So let's say 3.5. So let's suppose m, or the slope, is equal to 2. And what you do next is, let's get this point here, which is 4, 1, which is your x, y. So we plug in that to our point slope form using this and the slope. So let's do that. Y minus, so this is your x1, y1. Y minus y1, which is 1, is equal to the slope 2 times x minus x1, 4. And then simplify. Distribute 2 times x is 2x, 2 times negative 4 is negative 8, and then add 1 both sides. So y is equal to 2x minus 7. So this is the equation of that line. So that is by using the point slope form. Next one is, how about writing the equation of a line using 2 points? You see the 2 points here at -3, 0, and 0, 1. We can solve for slope. I'm going to write the points here, -3, 0, 0, 1. So this is your x1, y1, x2, y2. So the slope, remember y2 minus y1, so 1 minus 0 over x2 minus x1, 0 minus -3. 1 minus 0 is 1, 0 minus -3 is +3. So the slope is 1/3. And maybe let's use this. x1, y1. You can actually use the other one too. So using the point slope form, so y minus 1, that's your y1, equals the slope 1/3 times x minus 0. So distribute y minus 1, 1/3 x minus 0, and then add 1 both sides. So you'll have y equals 1/3 x plus 1. And this is the equation of this graph here. Okay? Next, examples. So write the point slope form of an equation of a line with a slope of 3 that passes through the point 6, -1. So remember again the point slope form. Y minus y1 is equal to m times x minus x1. So let's say this is your x1, y1, and you have the slope of 3 here, so meaning m is equal to 3. So to write that, y minus -1 equals 3, which is the slope, times x minus x1 minus 6. Y minus -1 is y plus 1. Distribute 3, 3x, 3 times -6 is -18, and then subtract 1 both sides, and you will have y equals 3x minus 19. Okay, let's try another one. Write the point slope form of an equation of a line that passes through the points 5, 1, and 8, 7. Then we write in the slope intercept form. Slope intercept form, remember, that is y equals mx plus b. This one is the slope intercept point slope form. Point slope form and slope intercept form. So you have the 2 points. So let's say this is x1, y1, x2, y2. So first solve for the slope. y2 minus y1, 7 minus 1 over x2 minus x1, 8 minus 5, 7 minus 1 is 6 over 3 is equal to 2. Then use the point slope form. Y minus, let's use this. Y1 is 1 equals slope is 2 times x minus 5. So y minus 1 is equal to distribute 2x, 2 times negative 5 is negative 10. And then if we add 1 both sides, y equals 2x minus 9. Next, writing and interpreting an equation for a linear function. So given the graph here, figure 9, and given the 2 points 0, 7 and 4, 4. We are not given a slope, so we can solve for slope, right? So this is your x1, y1, x2, y2. So to solve for the slope, change in y, y2 minus y1, 4 minus 7, over the change in x, 4 minus 0, and 4 minus 7 is negative 3, 4 minus 0 is 4. And again, using point slope form, remember again, y minus y1 is equal to m times x minus x1. So let's use this. So y minus 7 is equal to negative 3/4 x minus 0. So when you distribute, negative 3/4 is 0. And then add 7. So y is equal to negative 3/4 x plus 7. Easy, right? So next one. Writing an equation for a linear function. So how are we going to write an equation given this graph f, figure 10? So all you have to do is identify any 2 points that is on the graph. So let's say you have the y-intercept 0, 2, and what else? What, this one? That is 0, 2, and negative 2, negative 4. So let's do the same thing. Now you have the 2 points. All you have to do is first is solve for the slope. So x1, y1, x2, y2. So the slope is change in y, negative 4 minus 2 over negative 2 minus 0. Negative 4 minus 2 is negative 6 over negative 2, which is equal to positive 3. And then slope, point slope form. So again, let's use this. Y minus y1 is 2 equals m is 3 times x minus x1 is 0. So y minus 2 distributes 3. 3 times x is 3x. 3 times 0 is 0. Then add 2 both sides, so that y equals 3x plus 2. So this is our equation of that line. Whereas the y-intercept, so remember, just to recall, 3 is the slope, and the y-intercept is when b is equal to 2. That is, the coordinates at this point is 0, 2. Okay, next. Actually, this is from the previous. We already solved it. So we use exactly the same 2 points. You can choose any 2 points from the graph, and that's what we did, 0, 2, and -2, -4. And we were able to get the equation of the line, y equals to 3x plus 2. Okay, next example. How about modeling real-world problems with linear functions? So don't forget y equals mx plus b. So example number 8. Suppose Ben starts a company in which he incurs a fixed cost of $1,250 per month for the overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function C where C of x is the cost for x items produced in a given month. So let's identify what we have here. The fixed cost is present every month, which is $12.50. And the cost that can vary include the cost to produce each item, that is $37.50. And the variable cost, which we call it the marginal cost, is represented by $37.50. So we can write in terms of C of x here, it is equal to the cost at the beginning, $12.50 plus $37.50, x. So that is the answer. So let's say, for example, Ben produces 100 items in a month. How much is his monthly cost? So all you have to do is substitute that 100 to the x. So you can compute for C of 100. So that's equal to $12.50 plus 37.5 times 100. And when you compute that, that's going to be equal to 5,000. So this is just an example. So his monthly cost would be $5,000. Okay. Let's have another example here. Writing an equation for a linear function given 2 points. So we have here f of 3 equals -2 and f of 8 is equal to 1. That's the same thing as f of 3 equals -2 is 3 -2. F of 8 equals 1, that is 8, 1. So we have here x1, y1, x2, y2. So we can solve for slope. Change in y over the change in x. 1 minus -2 is 3. 8 minus 3 is 5. Then, again, let's use the first. So y minus y1, -2 equals the slope times x minus x1. Y minus -2 is y plus 2. Distribute 3/5 x. 3/5 times -3 is -9/5. And then we add 2 or subtract 2. Sorry. So y equals 3/5 of x. When we subtract this, that's going to be equal to 19/5. Okay, what do we have next? So we know that from a given function f of x equal to mx plus b, m is the slope and b is the y-intercept. So let's say m is 15 and your b is 200, then we can have this n of t is equal to 15t plus 200. That is, let's use that for example number 10. Using a linear function to determine the number of songs in a music collection. Marcus currently has 200 songs in his music collection. Every month he adds 50 new songs. Write a formula for the number of songs n in his collection as a function of time t, the number of months, and how many songs will he own in a year. So we have that formula, n of t is equal to 15t plus 200. So because the starting point, Marcus has 200 songs and he adds 15 new songs every month. So how do we solve this? How many songs will he own in a year? How many months in a year? There are 12 months. So meaning we can solve for n of 12. So 15 times t at time t in a year, 12 months, plus 200. 15 times 12 is 180 plus 200. So that is going to be equal to 380. So 380 songs in 12 months in a year. Okay. And last example. Example 11. Using a linear function to calculate salary plus commission. Working as an insurance salesperson, Ilya earns a base salary plus a commission on each new policy. Therefore, Ilya's weekly income depends on the number of new policies, that is n, he sells during the week. Last week he sold 3 new policies and earned $760 for the week. The week before he sold 5 new policies and earned $920. Again, the week before he sold 5 new policies and earned $920. Find an equation for I of n and interpret the meaning of the components of the equation. So again, we want to find the equation for I of n. So what given information do we have here? So we have 2 input-output pairs. And what are those? That's $3 and $760 for the week. So 3, 760 and 5, 920. So we have it here. And 5, 920. And remember, you can solve for the slope. This is your x1, y1, x2, y2. So 920 minus 760 over 5 minus 3. And that is 920 minus 760 is 160. 5 minus 3 is 2. So the slope is $80 per policy. So now how do we find an equation for L of n? So we know y equals mx plus b. So we have the slope of $80. So this is in terms of I of n. So that is 80n plus b. Now how do we solve for the initial value. So you can use this. You can plug in, this is your x and this is your y. It's like your x and this is your y. So that is 760 is equal to 80 times 3 plus b. And then 80 times 3 is 240 plus b, and then subtract 240 both sides. That is 520 is equal to your b. So that is the initial value. So now we can write our final equation. So I of n is equal to 80n plus your b is 520. So our final interpretation is that Ilya's base salary is $520 per week, and he earns an additional $80 commission for each policy sold. So that's why we have this equation, 80n plus 520. And that's it for this section 2.1. Thank you.